Alrighty, ladies and gents, in this video we're going to go over how do we actually come up with the equation of the tangent line to a function. And so the great news is, if you remember, the slope of a tangent line is precisely the derivative. So all we need to do for this is a pretty straightforward process is find the derivative, evaluate that derivative, meaning plug in our x value, that'll give us our slope, and then we can just create the equation of a tangent line. All right, so here we go. So for example, I'm going to do just one example in this video. So for example, they want us to find the equation of the tangent line to f of x equals x squared minus 5x plus 2 at the point x equals 2. So perhaps before I even start this one, let me just go ahead and write down the steps that we should do for this, okay? So the first step is find the derivative. Find f prime of x using the rules we discussed in the previous video. Your next step is to evaluate, aka plug in, evaluate your derivative at your x value, meaning just plug in that x value into the derivative, and guess what? This is the slope of the tangent line. Okay, this is actually the numerical value of the slope of the tangent line at that particular x value. I apologize for my handwriting. And the third step is, if you remember way back in your algebra day, if I know a point, an ordered pair, and if I know the slope, then I can use the point slope formula to come up with the equation of a line, which is y minus y1 equals your slope times x minus x1, where x1, y1 is your ordered pair. All right, so let's get this thing started here. So I'm going to highlight it up here. So f of x is x squared minus 5x plus 2. So to find the equation of the tangent line, first step is, hey, let's find the derivative. Okay, and so if you need a refresher on derivatives, go back to the previous video on power rule and the sum and difference rule. But the derivative of x squared is a 2x, negative 5x is the derivative of negative 5, and the derivative of a plus 2 is 0. So that's our derivative. Okay, the next step says to find the slope of the tangent line. So I'm going to use this notation, m tan. So slope of the tangent line means I need to evaluate my derivative at the given x coordinate, which in our case is 2. They told us they want us to find the equation of the tangent line, specifically where the tangent line touches the graph at x equals 2. So what does that mean? That means we're going to plug in 2 into the derivative. That's how we get the slope. So f prime of 2 equals 2 times 2 minus 5. That's 4 minus 5, which is a negative negative 1. All right. The last and final step here is plug all of our information, into the point slope formula. All right. Okay. Well, here's the deal. We know x1. We know x1 is equal to 2. What we do not know is they did not give us y1 directly. They didn't give us the y value, the y1 directly. So before we jump into the point slope formula, let's see if we can go ahead and calculate y1. And to get y1, what you do is you take your same x value of 2, and this time you plug it into the original function. And we know that from our function notations, right? To get my y value, I just simply plug in an x value. But I'm plugging it into the original function. So here we go. So see if I can put both of these up here. So it's x squared, so it's going to be, so y1 is going to be f of 2. So the original f function evaluated 2, which will be 2 squared minus 5 times 2 plus 2. Okay, so I can scroll up a little bit. So then that indicates we have 2 squared, which is 4, minus 10 plus 2. 4 minus 10 is a negative 6. Negative 6 plus 2 is a negative 4. Okay? All right. So that is now our y1. Now, grab a different color here. Now we can plug everything into our point slope formula. Now we're ready to go. Here we go. So the slope of the tangent line will be y minus our y1, which is a negative 4, equals the slope of, what was the slope of our tangent line? Our slope of our tangent line was a negative 1 times x minus our x x value, which was a positive 2. A positive 2. Okay? All right, let's clean this up a little bit. So y minus a negative 4, we know it's the same thing as y plus 4. And I'm going to distribute my negative 1 to every term in my parentheses. So it's going to be a negative 1x. I'm just going to write negative x. Then a negative 1 times a negative 2 is a plus 2. Our last step is to subtract 4 from both sides. We are done. So the equation of the tangent line is y equals a negative x, and then 2 minus 4 is a negative 2. Okay? So what the heck does that mean? That means this, folks. It means that what we had initially, if you go to f of x, the graph of f of x looks something like this. It looks something like that. Okay? And what we're saying is hey, let's say x equals 2 is, I don't know, somewhere here. What we're saying is the equation of the line that glances just there, we're saying the equation of that line is y equals a negative x minus 2. That's what the tangent line is showing you. And what we're going to figure out as we advance in this course is we can use that information to actually make a prediction or to make a guesstimate about a future value. Okay? And that's coming down the line, but yes. So to recap, how do you find the equation of the tangent line? All right, what you want to do is you want to take your derivative. You want to plug in the x coordinate, okay, into that derivative. That's how you get the slope of the tangent line. Next, you want to use the point slope formula. Y minus y1 equals your slope times x minus x1. If they give you your y value already, if they give you an ordered pair, you're good to go. Just plug everything to the formula. If they do not give you the y value directly, what you do is you take your same x value and you plug it into the original function. And that's how you get the y1. Alrighty, folks, I know that was a quick little video, but hopefully that does the trick and that'll get you through your homework. I'll see you folks in the next one.